In this section, we're going to look at a concept called a reference angle. And so let's look at the definition first. The reference angle for any angle theta in standard position is the positive acute angle between the terminal side of theta and the x-axis. So if we were going to draw the reference angle for 50 degrees, we draw it in standard position, which means we use the positive x-axis as our initial side. We draw our angle of 50 degrees. We have our terminal side, so in this case, our reference angle would be 50 degrees. That's the angle between the terminal side and the positive x-axis. If we look at 130 degrees, we draw our angle of 130 degrees. So this is 130. Now, the reference angle is the positive acute. So that means it's going to be less than 90 degrees between the terminal side of theta and the x-axis. So in this case, our reference angle is this angle between the terminal side and the x-axis. Well, we know if we went all the way around, it would be 180 degrees. But 130 of that is outside our reference angle. So we'll subtract the 130 degrees, and we find that our reference angle is 50 degrees. So again, we have a reference angle of 50 degrees. If we had 230 degrees, and we wanted to know our reference angle, well, if we draw our angle in standard position, that puts us around here in the third quadrant. Now, our reference angle is the angle between the terminal side and the x-axis. You always go to the x-axis. Well, notice if we look at this, our angle inside between the terminal side and the x-axis is this. All of this 180 degrees is outside our reference angle. It's our theta, it's our angle, but our reference angle would be that whole distance of 230 degrees minus the 180 degrees. So we have a reference angle of 50 degrees. And one last one, let's look at 310 degrees. Well, we draw our angle in standard position, which means we start on the positive x-axis. We go around 310 degrees, which puts us in the fourth quadrant. Okay, we want to figure out what our reference angle is. Our reference angle is from the terminal side to the x-axis. Well, all 310 degrees was outside. It's not included in our reference angle. We know if we went the whole distance around, we would go 360 degrees. 310 of those are outside our angle, which leaves us a reference angle of 50 degrees. Now, we will work a lot with reference angles, and because we're going to be able to know functions of our reference angles, it's easier when we work with angles that are less than 90 degrees. So we're going to work a good bit with our reference angles. And let's just look at a quick way of finding them. And I think the best way is just to think it through. Draw your angle, and then you can see what you have to do to get your reference angle. But some of you do like little formulas. So in the first quadrant, our reference angle was simply theta. It was what our angle was when our angle ended up in the first quadrant. When we ended up in the second quadrant, though, and this is our angle theta, and we want our reference angle. Remember, we thought the whole way was 180 degrees minus what theta was. So in the second quadrant, it's going to be 180 minus theta. and that will give us our reference angle. When we got to our third quadrant, and we have our angle of theta, we just want the reference angle, the angle that's between the terminal side and the x-axis, which means we didn't need that 180 degrees, so our reference angle ended up being theta minus 180. And in the fourth quadrant, we rotate it around theta. We want our reference angle. Well, we know the whole distance around, the complete rotation's 360 degrees, minus whatever theta is, would give us our reference angle. So we have ways of finding our reference angle in every single quadrant. So we want to look at just a few and figure out what our reference angle is. So let's say that we have 95 degrees. And again, I always like to sketch me a picture. 95 ends up over here in the second quadrant. What we want is the angle between the terminal side and the x-axis. How many more degrees would it take us to get down to that x-axis? So that would be 180 minus 95, which would be 85 degrees. So we have a reference angle of 85 degrees. Let's take an angle of negative 216 degrees. Now what it means when we say negative is that we rotated clockwise. Well, that would be negative 90, negative 180. We would be up here in the second quadrant. So this is our 216. Now here's where we can't really use that formula. We have to look at what happened. Our reference angle is the angle between the terminal side and the x-axis. So we know that this whole amount was 216 minus the 180, which would give us a reference angle of 36 degrees. Now a reference angle is always positive. We don't have negative reference angles. It's an angle that we're referring to. Sometimes it's also called the related angle, as it relates to our other angle. Okay, and then let's look at 345 degrees. Well, if we think about drawing it, we're around here in the fourth quadrant. So what we need to know is how many degrees would it take us to get up to 360? So that would be 360 minus the 345. That's outside our angle. So that would give us a reference angle of 15 degrees. And we can also deal with reference angles. Let's say we have 523 degrees. Well, what we know here is we rotated around 360 degrees, and then we rotated past that. If we got down to our coterminal angle, we take our 523 minus the 360, and we're left with 163 degrees. So we rotated all the way around, then we rotated 163 degrees, so we're ending up over here in the second quadrant. So we know that we went to go all the way here would be 180. So we have the 180 minus the 163. So we end up with a reference angle of 17 degrees. Okay, you need to be able then to find reference angles. And our trig functions, as we look at them, then what we're going to see is our reference angles become very important. Let's say that we want to find the sine of 30 degrees. Now, we've already memorized the sine of 30 degrees. We know what it is, but let's look at it in terms of our reference angles. If we wanted to do 30 degrees, then let's just go back to our definition. A point on the edge, remember the side opposite the 30, which is your y, is half the hypotenuse. The side opposite the 60 is the square root of 3. So our x is square root of 3 and our y is 1. So the sine of 30 degrees then, and our hypotenuse would be 2, was y over r, so 1/2. And we already knew that. Okay, let's look and say we want the sine of 150 degrees. Well, what we've already looked at is if we rotate around 150 degrees, what's left here is 30 degrees. We have a reference angle of 30 degrees. But we're in the second quadrant, so in this case our x is negative, our y is positive, and r is always positive. So we ended up with negative, or positive, excuse me, 1/2 for the sine of 210 degrees. We're going to rotate around 210, and notice for 210 we ended up in the third quadrant, so 210 minus the 180 would be 30. We had that reference angle of 30 degrees. Now, if we're picking a point on our terminal side, in this case our x is negative and our y is negative. Our r is still positive 2. So our sine ended up being negative 1/2. And the sine of 330 degrees. Rotate around 330 degrees. Well, we lacked 30 degrees being up to the x-axis, so our reference angle is 30. So if we pick a point, our x here is positive, our y is negative, r's always positive, so our sine ended up being negative 1/2. Now notice for all these angles, our reference angle was 30. We know what the sine of 30 is. So all we have to deal with is which quadrant are we in. And so when you know your reference angle, if it's one that you already have memorized, then all you have to do is figure out which quadrant you're in. And you don't have to do all the drawing. Let's say we want the cosine of 315 degrees. Well, let's think what our reference angle is for 315. We need 45 degrees to get to the x-axis, 360 minus 315. We know the cosine of 45. It's square root of 2 over 2. We're in the fourth quadrant, so the cosine is positive. That's where you've got to remember they're all positive in the first, the sine and its reciprocal in and the tangent and its reciprocal are positive in the third, and the cosine and its reciprocal are positive in the fourth. If we want the tangent of 120 degrees, well, let's think first of all, 120, that means our reference angle is 60 because 180 minus 120 is 60. We know that the tangent of 60 is the square root of 3. We're in the second quadrant, so we know the tangent's negative. So we're able to go directly to the answer. If we want the secant of negative 300 degrees, well, negative means we rotated clockwise, so we would be here. So we need 60 degrees to get to our positive x-axis. So our reference angle is 60. Now, secant is the reciprocal of cosine. The cosine of 60 is 1/2, so the secant of 60 is 2. We're in the first quadrant, so it would be positive. And if we wanted the cotangent of 420 degrees, well, first of all, let's see what our coterminal angle is. So we'll subtract 360, and our coterminal angle is 60 degrees. So we went all the way around, and then we went 60 degrees more. Now, the tangent of 60 is square root of 3. So the cotangent of 60 is 1 over the square root of 3, or square root of 3 over 3. And we're in the first quadrant, so it would end up being positive. So we can deal with our functions, finding our angles, uh, using our uh, reference angles. Now let's look at a few where we're going to use our calculator to find these. And it's not hard to find these. We'll still have to deal with some things. So we're going to look at several together. Okay, we have some angles here that we want to find our function for. We're going to use the calculator. Now, first of all, we want to make sure we're in the degree mode. So if not, then put your calculator in the degree mode. And then for cosine, there's not a difficulty. We press cosine 347, close our parentheses, and enter. And we're going to round these off to 4 decimal places. So that means we've got a decimal 1, 2, 3, 4. The 3 is in our 4th decimal place. And so we can see that the next number is more than 5, so we would add 1. So decimal 9744. Okay, let's look at the tangent of 215. We would simply put tangent 215. So going to 4 decimal places, it would be our decimal 7002. Okay. The sine of 305. Okay, would be negative. Now see, we're in the 4th quadrant, so it turns out to be negative decimal 8192. 8192. Okay, now the next one's cosecant. So let's think what we need to do. We don't have a cosecant button. Cosecant is the reciprocal of sine. So remember what we do here is we put the cosecant of 100, we close that parenthesis, and then we do our reciprocal. The cosecant is the, excuse me, I said sine, but I wrote cosecant here. So that means that we take the sine of 100 and then we take the reciprocal. The cosecant is 1 over the sine, or the reciprocal of that. So if we go to our calculator then, we're going to do the sine of 100. We'll close the parenthesis, then we will say reciprocal. And so we get 1.0154. 1.0154. It was in the 2nd quadrant, so it was supposed to be positive. Should put that up here. Now I said that we could do that a second way. Another way of doing it would be to do 1 divided by the sine of 100. If you're in doubt of how to use your reciprocal button, and that gives us the same answer. Now the cotangent is the reciprocal of tangent. So we would put in tangent 459, close the parentheses. Now we want the reciprocal of that. So we end up with negative decimal 1584. So it's not difficult to use your calculator when you're dealing with your other angles. The problem comes when we're looking for the angle, because your calculator can only give you one answer. And because of some things that we'll look at later, which are called inverse functions, then your calculator's programmed to give you your answer in a specific way. And it's not always the way that we want the answer given. So let's look at some problems. Let's say that we want to know the sine of what angle equals negative 0.3090. Now, right here we need some other information. We know the sine is negative in the third quadrant and the fourth quadrant. So we need to know which quadrant. Let's say we want it in the fourth quadrant. Okay, we'll go to our calculator. Now remember, when you're looking for an angle, you do the inverse sine. So we're going to do second sine, and then we can put in our negative 0.3090. Close our parentheses, enter. Now, it gave us negative 17.99, or negative 18 degrees. And negative 18 degrees is in the fourth quadrant. But what we want is our theta. We basically have the reference angle here. We're wanting our theta, so we're wanting the angle as it rotates around counterclockwise. We want it in standard position. So what we need to do is recognize what we have is the reference angle. Well, notice all the way around would be 360 minus that 18. So we want 360 minus 18, and that will then give us our angle of rotation. But that's between 0 and 360. We normally want our angles between 0 and 360. So we get 342 degrees. Now you could do this on your calculator if you stop to think about it. 360 minus 18 is the same as negative 18 plus 360. And we have our 342 degrees. But we always want to give our angle between 0 and 360. So if you end up with an angle that's less, then you're going, or negative, then you're going to have to get the correct angle. Suppose we wanted this in quadrant 3. We said we wanted it in quadrant 4, but since it was negative, we could have wanted it in quadrant 3. Now, we would have gotten that same answer, but we needed to put our angle in quadrant 3. So what we need to recognize is that 18 is our reference angle. It was the angle between the terminal side and the x-axis. So it's our reference angle. So in this case, to get our angle of rotation, we're going to have to go 180 degrees plus 18, 180 plus 18, which gives us 198 degrees. So you do have to look at which quadrant you want your angle in, and later on we'll have to give both of them. But we could go back and check this. We could say the sine of 342 degrees Yes, that's negative 0.3090, or the sine of 198 degrees gave us the same answer. So you do need to watch which quadrant that you are giving your answer in. Okay, let's look at another one. Say that we want to know the tangent of what angle is equal to 0.5890 in quadrant 1. Now again, we're looking for an angle, so what we're going to do is the inverse tangent of 0.5890. So we'll look at our calculator. We'll do second tangent, 0.5890. Now, anytime it's positive, it is going to end up in the first quadrant. All of our functions are positive in the first quadrant. So we've got 30 degrees. If we want the secant of what angle is equal to negative 3.4159, and we're going to be in quadrant 2. Now the reciprocal of secant is cosine, and we would have the reciprocal of this number. We just simply took the reciprocal of both sides. So what we're going to do is the inverse cosine of negative 3.4159, and it's this number we're wanting the reciprocal of, so we put our reciprocal inside our parentheses. Or again, if you're not sure, put 1 divided by. So we go back to our calculator, and we're going to do second cosine, negative 3.4159, reciprocal, close parentheses, enter. Now notice for the cosine, it gave it in the second quadrant. It's 107 degrees. So we've got 107 degrees. Now that was because we wanted it in the second quadrant. What if we had wanted it in the third quadrant? Cosine's also negative in the third quadrant, so we could have been asked the third quadrant. Well, what you have to think here, and you've got to do a little bit of thinking, we got 107 degrees. We actually want our angle in the third quadrant. So what we need to know is our reference angle. We need to know how many degrees it took us to get to our x-axis. So we would do 180 minus 107, and we get that our reference angle is 73 degrees, is 73 degrees. Now, if we have a reference angle of 73 degrees in the third quadrant, then that means that we rotated around 180 plus 73, which gives us 253 degrees. It's very important for you to recognize which quadrant you're supposed to be in. And your calculators, as I said, it's programmed to give the answers in a certain way. You have to do the thinking to know where you're supposed to end up. Okay, let's look at one more. Say we want the cosecant of theta is equal to negative 1.7876, and we're in quadrant 3. Now cosecant is the reciprocal of sine. So we can do the sine of theta equals 1 over or we're wanting the inverse sine of negative 1.7876, and we want the reciprocal of that number. Or you can just put in 1 divided by. So we go to our calculator, we'll do second sine, or inverse sine, negative 1.7876 reciprocal, close parentheses. We're wanting the reciprocal of the function. Well, that gives us negative 34 degrees, which is basically our reference angle. It gave us negative 34. Now, if we were wanting this in the fourth quadrant, then we would say 360 minus 34, and we would get our angle in the fourth quadrant. But we want it over here in the third quadrant. That means that 34 degrees, not negative 34, but 34 degrees is our reference angle. Reference angles are always positive acute angles. So we are going to rotate 180 degrees plus 34 more. So our angle is 180 plus 34, which is 214 degrees. Okay, so your calculator will give you, in many cases, it will give you the reference angle, and it may often give it to you as a negative angle because you're in the fourth quadrant. So you have to recognize how to put that in each quadrant. Okay, let's look at our special angles, the ones that we know by memory, and look at how we would go about doing these. We already saw that we can think what our reference angle is. So and how that since they all have the same reference angle, all we need is the quadrant. So let's look at, we want the sine of what angle is negative square root of 3 over 2, and we're going to be in quadrant 3. Now, first of all, you think reference angle. The sine of what angle square root of 3 over 2? Well, that's 30 degrees. Those are the ones you're supposed to have memorized. The sine of, 60 degrees. The sine of 30 is 1/2. The sine of 45, square root of 2 over 2. The sine of 60, square root of 3 over 2. So you think back to the memory work that we've done. So we know that our reference angle is 60 degrees. And we want to be in the third quadrant, so we'll draw this. Our reference angle 60, so our angle theta is 180 plus 60, so theta would be 240 degrees. Okay, if we wanted to know the tangent of what angle is square root of 3 over 3. And some books may actually put that as 1 over the square root of 3, where they don't rationalize it. I've told you to memorize it as a rationalized answer, but it may be either way, but all you have to do if it's not rationalized is rationalize it. So we want the angle whose tangent square root of 3 over 3, and we want our answer in the third quadrant. We know tangent's positive in the first and third. So the first quadrant, it's your reference angle. The third quadrant, then we'll have to find our value. Well, we know that that's 30 degrees. The tangent of 30 is square root of 3 over 3. And we're wanting to be in the third quadrant, so 30 is our reference angle. So we're going to rotate around 80 degrees plus 30 more, so our angle is 210 degrees. Okay, if we want to know the secant of what angle is square root of 2, and we're in the fourth quadrant. Well, we think reciprocal. The reciprocal of secant is cosine. The reciprocal of this is 1 over the square root of 2, or square root of 2 over 2. So we think, what angle has a cosine of square root of 2 over 2? Well, 45. And we're in the fourth quadrant, so our reference angle's 45. So our angle is 360 minus the 45, because all the way's 360, but we didn't go that 45. So 360 minus 45 is 315 degrees. So what we're looking at here are our reference angles and getting some functions of our angles. Now, if you haven't memorized your special angles, sine, cosine, and tangent for 30, 45, 60, and for your quadrants, 0, 90, 180, and 270, then you need to make sure that you do get those memorized because we will be using them a lot. Those are the angles that we'll use them the most, and you need to be able to get your answer right away.